Good morning or good evening, whatever. So here we are doing this question, and then they ask us to find the position of a neutral axis from the bottom, the second moment of error about NA, and the least sectional modulus. Right? So let's start. How do we do this? Right? The first thing we do, before you do anything, the first thing you do, you must have a reference. Right, so I'm gonna choose the bottom part as my reference. Always you can still choose the top, does not matter. Right, you can choose the bottom part reference, the bottommost. What do I mean about the bottommost? Major, not here, but the bottommost. Right, to avoid many things, you can choose whatever position you like, but for me I like to choose it the bottommost. Okay, so this question asks us to find what the position of the neutral axis. So they ask us to find NA, right? So since we are given these values, so we're gonna use the blue book. So how do we use the blue book? Hey, this is the major question. How do we use the blue book? Right, first of all, we need to identify the parts. So how many parts are we given? So we are given what? We are given number one a channel. This is a channel, and then number two a I section. A I. Why is the I? Because these values are not equal, so it cannot be an H. So this is an I section, right? That is number one. So we are given only two parts for this question. Only two. It's easy, man. It's easy, saint. So we are given only two. So how do we find the position of a neutral axis? So here we are given two things. So this is a composite cross section, right? So the formula that we use to find a neutral axis for a composite is this one. Y bar is equal to sum of y bar over sum of A. Don't be confused. This is the y bar for the whole composite, and then this is the y bar for each part. Right? So in this case, there are two parts. That means there are two y bar. Right? This is how you find it. So if they ask you, for example, in the x direction, so it's the same thing, x times A over sum of A. Right? So how do we do it? So this is A. So how do we do it? For this thing, we're gonna use the table method. I think the table method is the easiest. So in the table of method, just follow the formula. So we need to have a part, obvious, and then we need, for each part, we need an area for that part. And then what else do we need? We need the y bar for that part, right? And then finally we need y times A. Y bar times A. That's it. There's nothing difficult about that, right? So let's start so that I can show you how to use Blue Book. So let's start with part number one. So part number one is a channel, and then that channel has these dimensions 300 by 100. So you go to your Blue Book, and then under channels, and then there's it, 100 by 300 by 100. That's it. Now we have this part, right? So part one is what? A channel, and then we need an area for the channel. So how do you do? So there's it 300 by 100, and then area is what? So it's written here, area is what? 5,76 times 10 exponent 3. So it's gonna be 5,76 times 10 exponent 3. Take note of the unit, millimeter squared. Right? That's it. Now we have to find what? Y bar. always remember this, please. Y bar always start from the reference to the centroid of the part. So each part has a centroid. For example, part 1 has a centroid. If you don't know the centroid, always come to Blue Book. Right? Here, there's a channel. You always check where does YY and XX meet. So in this case, YY and then XX always meet here, somewhere here. So take note of the orientation. So obvious, it's like this on Blue Book, but for this question, it's like this. So it's gonna meet, when you superimpose, it's gonna meet somewhere. This is your centroid for the channel, right? Yeah, it's somewhere here, right? Now you calculate the distance from here, reference, to this point, right? So we need to know the height of this, obviously, and then we need to know the height of this, right? So most people are confused because these are sticks, right? In reality, let me just redefine this drawing. This drawing is like this. We have a channel, so it's like this. So we have a channel like this, and then we have an eye section like this. And then this is our reference. So in reality, so the stick is just for representation, but in reality it's like this. So everything has a thickness, right? And a centroid is somewhere here for this, and then for an eye, yeah. And then let's go and check. So we want a distance from here up until here, right? So obviously we need to find a distance from here for the host, for this whole eye section, and then we need to add this distance from here to here, right? So while are we still in the eye section, you what we call this, you checked. So in this case, you must keep the orientation as it is. So in this case on Blue Book, they say this is YY. So you again, you say this is YY, and then this is XX according to Blue Book, right? So now we need to know the distance from here to here. So you check. We have this and this, but we want a centroid, guys. Don't waste your time. So we already know from, look, AY is the distance from here to here. This is what we're looking for. So then you come to AY. Where is AY? Remember, for a what? For a 300 by 100. So this is your AY. It's 30,6, right? So the distance the distance from here to here, it's AY, right? And then AY is got what? 30,6. Then you come here, right? This is the distance from here to here, right? Remember, when you are doing this one, you need to always come from the reference. So the reference is this. So it's gonna be this height of the eye, and then plus this AY. So you need to know the height of this eye section. So now again, you go to Blue Book, and we are given the value. They say it's 352 or 356. Don't know why there are two numbers, but let's go and check. Where is 356? So now we are in the, this is not what we are looking for. We need the pure eye section. Oh, here are the pure eye sections, right? So we need what? 356. Here is 356. We don't have a 52, so we're gonna deal with 356 by what? By 171. And then they say it's what? I think it was times 49. Times 49 in the question. It was in the question. So it's this one, right? So the true values is 352 plus 171. So it's 356 times 175 times 45. So it's the first one, right? We need the height. So the height is what? 352. Take note of the orientation. So again, the I section is exactly as it is. So there's no need to change. So the IX, this is IX for the I section, and then this is YY for the I section, right? So the height, as you are given from the blue book, you always take this height, not this HW. You're gonna get wrong answer because HW has what, a radius somewhere. So you always take the height. So the height is what? H. So the height for this is what? 352. So from here directly to here where it starts is what? 352. Right? So now from here reference to this, it's 352 plus 30. Now let's go and add. So it's gonna be 352 plus 30,6. So from this Y bar for the channel C is what? 382,6 millimeters. Right? So from here up until here, you first add 352 and then AY, right? Always. Does not mean don't ever use these values. 356. Remember, must always use these ones. H. Even though you see, for H in this case is what? 352. You see? I didn't use 356 because for 45 you have 352 and 171. Don't use 356. 356 is just an indication. You always use the H and the B, right? If they are the same, they are the same. For example, yeah, always use the 356 because if you do, this is just an what? It's like rounding off, but this is the actual value for the I section with 45. So use 352. So 352 plus 30,6. You have this answer, right? Done. Then obviously you can calculate this and this. So let's go to the I section now, another part. So what is the area of this I section? So again, this one, so we are given 5,7. So it's gonna be 5,7 times 10 exponent 3. Take note, they say times 10 exponent 3 millimeter squared, right? And then what is my Y bar? So again, from the for example, go and check first, where does x, y, and x meet? So x and y, they meet, you can see it's the center. So they meet here. So for the I section, this is your Y bar, right? And then you start from the reference. So it's somewhere here from the reference here. Go just, this is the times divide by 2. It's just this whole section. Divide by 2 is half of this. So it's gonna be 352 over 2. Remember, you use this one, right? And then we multiply now. So it's gonna be 5,76 exponent 3 times 352,6. So here we have what? 2230377,6. This is millimeter cube, right? And then we have another 5,70 exponent 3 times 52 over 2. So we have this 100,3200. Then you can have a total here, or a total. So you can add these ones. Let me just first add these ones. 23037. So here we have a total of 233,06976. And then here we have 5,76 plus 5,70. So we have 11,46 times 10 exponent 3. Then our y bar is what? It's gonna be 22306976 over 11,46 times 10 exponent 3. Take note of the unit. So it's gonna be 2230,6976 divided by 11,46 exponent 3. This is not okay. There's something wrong somewhere. There's something wrong somewhere. You see, let me check. So we have 382,6 times 5,76 exponent 3. So we have 22. Yeah, I told you. There's no 3 here. So it's gonna be 0. Right. You must always use logic, guys. 352 over 2 times 5,70 exponent 3. So this one is okay. So let's just add 2203776. So we don't have this number. So this number is 326976. So it's 32606976. Then divide by 11,46 exponent 3. So the final answer is 279,84 millimeters, right? So from the wrist reference up to the neutral axis, let's write it in the new one. So from here to here, this is 2,79,84 millimeters. Now the question says from the bottom. So obvious, we did take our reference from the bottom. But let's say if this is from the bottom, but let's say the question asks for the top, you can still use the same thing, and then you just come at the end, you say, what is the total distance here? So we have 352 plus the distance of the channel. Obvious, it's 100. Yeah, it's 100 plus 100. So the total is what? 352 plus 100. So the total distance here is 452, right? So if they ask you from the bottom, from the top, you just say y bar is what? 452 minus 279,84, which is equal to, so 542 minus 279,84 is equal to 172,16. Yeah, millimeters. This is from top, right? You can still use the same reference bottom, and then you conclude like this, because the total distance from here to the toppest is 452, and then you minus this one, then from the top, then you are done with number 1. Then you can just draw your table nicely with the total here. Yeah, it's messed up, but I think you get the idea. Right, now let's go to B. B says second moment of inertia, right? The formula that you need to know in your head is Ixx is equal to Ixx plus A, you can say it's dy squared, whatever, it does not matter. So this is the moment of inertia of the part. This is for the whole part, and then this is for the part, and then the part, and the part. Then how do we do it? Again, we use the table method. So we have a part, and then we have Ixx, then we have an area, and then we have dy squared. Dy squared is just, take note, it's just y bar minus y bar. So this is for the total, this is for a part squared. That's it. So let's look at the part. Remember, use your reference, same reference. So the part is what? Number one part is in I section. So what is my IXX? Okay. Right. So the channel. Remember, IXX, take note of this. IXX will always be horizontal. IXX will always be horizontal. So IXX always horizontal. Then IYY, it's always vertical. So take note of those. So IXX is what? Always what? Horizontal. Then let's come to see. Here's our channel, right? First thing first, you put it as it is in your given question. So my channels is like this, right? So my IYY is now my IXX because it's the one that is horizontal now. If you put it like this, you see. Then you come here, you do not grab IXX because IX is for the position when it's like this, but in this case, the position is like this. So we're gonna use IYY as our XXSY because IXX is always horizontal. So when I put it first like this, and then my horizontal one is what? Is my YY. Then you come here to your blue book, and then you search for the channel. Don't go to XX, you go to the YY. So we have 5,67 times 10 exponent 6. So I write it here. So it's gonna be 5,67 times 10 exponent 6. Take note of the unit, millimeter cube. Right? The area is the same, so it's 5,76 times 10 exponent 3. Then now my dy, this is conventional. So my dy is like this. Just know, you must know this formula. This is the parallel axis theorem formula. So what is it? So yt, remember you use the same reference. So again, we are coming from the bottom. So for yc, we found that it was 279. So it's gonna be in bracket 27,984 minus, what is my y for the part? The channel. So it's gonna be 382,6 then squared. So it's like this. Done. Then you move to the next part. The next part is in I section. Right? What is the? You go to the I section. You do the same thing. Right? First of all, same orientation. Right? So it's like this. Here it's like this. Whose horizontal here is XX. So that means you take the XX because IXS is always horizontal. But if the channel, if the I was like this, we would have taken IYY. So in this case, we are taking IXX as it is. So my IXX, take note, my channel is what? 352, yeah, it's this one. And then you go to here, 121. So it's gonna be 121, then times 10 exponent 6. This is 4, not cube, 4, right? And then the area is still the same, 5,7 times 10 exponent 3. Then what is my yt? Is still 279,84. What is my y for the part? 352/2 all squared. Then you just calculate your ix. So just calculate. So for the first one, so it's gonna be 5,67 exponent 6 plus the area 5,76 exponent 3 times in bracket 279,84 minus 382,6 squared. Don't forget. So we have this answer 6649337,38. Take note of the unit, mm4, right? And then you do it again. 121 exponent 6 times plus 5,70 exponent 3, 279,84 exponent minus 84 minus 352 over 2 all squared, right? So our answer is what? 182,461,649,9, right? And then you write here total, right? Always remember, for the moment of inertia or second moment of inertia, there's no total, there's no total, there's no total. Don't add these things, right? Just add the last part, this one. So it's gonna be this plus 66493397,38. So we have the total of 248955047,37 millimeter 4. That is our answer, right? We just add, right? Then lastly, they ask us for a least modulus. So least modulus, right? What is the formula for a least modulus? It's just Z is equal to Ixx over Y. So the least obvious, Y mean. So between the two, if you are coming from the top, bottom is what? 279. If you are coming from the bottom is 172. So it's gonna be 2,489,350,57 divided by 172. That's it. So it's gonna be 172,16. So the answer is what? 1446067,88 millimeter cube. So this is the answer. Nice 30 minutes, guys. So if you are given the complicated part, this is how you do it. You write every part and then you just follow the same method. It's nothing difficult here. It's nothing difficult. Thank you.